Chapter 2 Acids, Bases and Salts. Collect the samples of hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, and ammonium hydroxide. Put a drop of each of the above solutions on a watch glass and test with a drop of the phenolphthalein indicator. What change in color did you observe? These indicators tell us whether a substance is acidic or basic by change in color. How do acids and bases react with metals? The apparatus is set. Take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Pass the gas being evolved through the soap solution. Why are bubbles formed in the soap solution? Take a burning candle near a gas-filled bubble. What do you observe? Repeat this activity with some more acids like HCl, HNO3 and CH3COOH. Are the observations in all the cases the same or different? Note that the metal in the above reactions displaces hydrogen from the acids. The metal combines with the remaining part of the acid and forms a compound called a salt. How do metal carbonates and metal hydrogen carbonates react with acids? Take two test tubes, label them as A and B. Take about 0.5 grams of sodium carbonate Na2CO3 in test tube A and about 0.5 grams of sodium hydrogen carbonate NaHCO3 in test tube B. Add about 2 ml of dilute HCl to both the test tubes. What do you observe? Pass the gas produced in each case through lime water calcium hydroxide solution and record your observations. The reactions occurring in the above activity can be written like this. On passing the carbon dioxide gas evolved through lime water, white precipitate of calcium carbonate is formed. Once again after passing carbon dioxide evolved, calcium bicarbonate is formed. Limestone, chalk and marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, carbon dioxide and water. How do acids and bases react with each other? Take about 2 ml of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. What is the color of the solution? Add dilute HCl solution to the above solution drop by drop. Is there any color change for the reaction mixture? Why did the color of phenolphthalein change after the addition of an acid? Now add a few drops of NaOH to the above mixture. Does the pink color of phenolphthalein reappear? Why do you think this has happened? In the above activity, we have observed that the effect of a base is nullified by an acid and vice versa. The reaction taking place is written as aqueous solution of NaOH and HCl gives aqueous solution of NaCl and liquid H2O. The reaction between an acid and a base to give a salt and water is known as a neutralization reaction. In general, a neutralization reaction can be written as base and acid gives salt and water. Reaction of metallic oxides with acids. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. You will notice that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper chloride in the reaction. The general reaction between a metal oxide and an acid can be written as metal oxide plus acid gives salt and water. Reaction of a non-metallic oxide with base. In the reaction between carbon dioxide and calcium hydroxide. Calcium hydroxide is a base, reacts with carbon dioxide to produce a salt and water. Since this is similar to the reaction between a base and an acid, we can conclude that non-metallic oxides are acidic in nature. What do all acids and all bases have in common? We have seen that all acids have similar chemical properties. What leads to this similarity in properties? We have seen that all acids generate hydrogen gas on reacting with metals, so hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic. The bulb will start glowing in the case of acids. But you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of the bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the solution by ions. Since the cation present in acids is H+, this suggests that acids produce hydrogen ions, aqueous H+, in solution, which are responsible for their acidic properties. What happens to an acid or a base in a water solution? Do acids produce ions only in aqueous solution? Take about 1 gram solid NaCl in a clean and dry test tube and set up the apparatus. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer about the acidic character of first? Dry HCl gas, second HCl solution? This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H+ ion from HCl molecules cannot occur in the absence of water. HCl plus H2O gives H3O plus and Cl-. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus hydrogen ions must always be shown as aqueous H+ or hydronium ion H3O+. We have seen that acids give H3O+ or aqueous H+ ion in water. Let us see what happens when a base is dissolved in water. Bases generate hydroxide OH- ions in water. Bases which are soluble in water are called alkalis. Now as we have identified that all acids generate aqueous H+ and all bases generate aqueous OH-, we can view the neutralization reaction as follows. Acid plus base gives salt and water. Let us see what is involved when water is mixed with an acid or a base. Take 10 milliliters water in a beaker. Add a few drops of concentrated H2SO4 to it and swirl the beaker slowly. Touch the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? The process of dissolving an acid or a base in water is a highly exothermic one. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. Look out for the warning sign on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or base with water results in decrease in the concentration of ions H3O plus OH- per unit volume. Such a process is called dilution and the acid or the base is said to be diluted. How strong are acid or base solutions? We know how acid-base indicators can be used to distinguish between an acid and a base. We have also learnt in the previous section about dilution and decrease in concentration of H+ or O- ions in solutions. Can we quantitatively find the amount of these ions present in a solution? We can do this by making use of a universal indicator, which is a mixture of several indicators. The universal indicator shows different colors at different concentrations of hydrogen ions in a solution. A scale for measuring hydrogen ion concentration in a solution, called pH scale, has been developed. The P in pH stands for potens in German, meaning power. On the pH scale we can measure pH from 0, very acidic, to 14, very alkaline. pH should be thought of simply as a number which indicates the acidic or basic nature of a solution. Higher the hydronium ion concentration, lower is the pH value. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution. As the pH value increases from 7 to 14, it represents an increase in OH- ion concentration in the solution, that is, increase in the strength of alkali. Generally, paper impregnated with the universal indicator is used for measuring pH. The strength of acids and bases depends on the number of H+ ions and O- ions produced, respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar, then these produce different amounts of hydrogen ions. Importance of pH in everyday life. First, are plants and animals pH sensitive? Our body works within the pH range of 7.0 to 7.8. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into the rivers, it lowers the pH of the river water. The survival of aquatic life in such rivers becomes difficult. Second, What is the pH required for plant growth? Plants require a specific pH range for their healthy growth. Neutral pH, that is pH 7, can promote healthy plant growth. Third, pH in our digestive system. It is very interesting to note that our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. During indigestion, the stomach produces too much acid and this causes pain and irritation. To get rid of this pain, people use bases called antacids. Fourth, pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel, made up of calcium phosphate, is the hardest substance in the body. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food. Using toothpastes, which are generally basic, for cleaning the teeth can neutralize the excess acid and prevent tooth decay. Fifth, self-defense by animals and plants through chemical warfare. Have you ever been stung by a honeybee? Bee sting leaves an acid which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. More about salts. First, family of salts. Salts having the same positive or negative radicals are said to belong to a family. For example, NaCl and Na2SO4 belong to the family of sodium salts. Similarly, NaCl and KCl belong to the family of chloride salts. Second, pH of salts. Salts of a strong acid and a strong base are neutral with pH value of 7. On the other hand, salts of a strong acid and weak base are acidic with pH value less than 7, and those of a strong base and weak acid are basic in nature, with pH value more than 7. Third, chemicals from common salt. The salt is formed by the combination of hydrochloric acid and sodium hydroxide. Solution is called sodium chloride. This is the salt that you use in food. These large crystals are often brown due to impurities. This is called rock salt. You must have heard about Mahatma Gandhi's Dandi March. Common salt. A raw material for chemicals. The common salt thus obtained is an important raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder and many more.